Hello and welcome to our discussion of question 5 on the 2018 AP Calculus BC free response section. This question is on polar curves. As you can see in the diagram, there are two polar curves, one circle with a radius of 4, and a cardioid, which is the heart-shaped curve with the equation of r is equal to 3 plus 2 cosine theta, as given in the question sum below. Part A of question 5 asks for the area of the shaded region. A good test prep tip is whenever a calculus question asks for the area under a polar curve, you should break the diagram into sections. Here you can see the shaded region is bounded by the intersection points at each curve, and that the shaded region is inside the circle but outside the cardioid. This means you should find the area under the cardioid, which is given by the equation r equals 3 plus 2 cosine theta, and subtract it from the area under the circle, given by the equation r equals 4, between the radians of pi over 3 and 5 pi over 3. Pi over 3 and 5 pi over 3 are the radian measures of the intersection points given in the question sum below. To find the area under a polar curve, you need to remember the equation area equals 1/2 integral of r squared times d theta, where r is the polar curve equation. Next, plug r for each polar curve into the formula and subtract the area under the cardioid from the area under the circle, again integrating between pi over 3 and 5 pi over 3. Now we have an expression for the shaded area that is given here. You should note the question only asks for the expression and not for you to evaluate the equation. Question 5 falls under the non-calculator portion of the free response section. Therefore, unless an equation is easy to integrate, you will not be asked to evaluate it by hand. Moving on to part B, the question asks for the slope of the tangent line with the cardioid at pi over 2. The tangent line at pi over 2 looks something like this. We can see the line is positive and can later use this fact to double check our final answer after we are finished with part B. The trick to this question is that it asks for dy over dx. However, we are only given an equation for r in terms of theta, specifically r equals 3 plus 2 cosine theta below. Therefore, we need a formula that relates the rectangular coordinates for the y and the x to the polar coordinates, the r and the theta, given by the formula r equals 3 plus 2 cosine theta, which is this formula here. We also need two formulas to convert the polar or r equation into rectangular coordinates of x and y, which we also have here. Then we can plug r for 3 plus 2 cosine theta into the rectangular coordinate equations as we have here. And then we need to take the derivative of each equation with respect to theta. We can then, after distributing the sine and the cosine, use the product rule for the second term in each equation. Once we have the derivatives, we plug in the point given in the question, which is pi over 2, and we get 2 for dy over d theta and 3 for dx over d theta. When we plug 2 and 3 into the original equation, we get 2/3 as the slope of the tangent line. This slope is positive and appears consistent with the original tangent line that we drew. In the final part of question 5, part C, the question says a particle is moving along the cardioid between 0 and pi over 2 radians, which puts the path of the particle in this region here. The question then asks for the change in the radians over time, d theta over dt, when the particle is at the point pi over 3. The question also gives the change in the distance from the origin over time, dr over dt, of the particle as 3, indicating the particle is moving to the left. that is to say the distance between the curve and the origin, which is at the center here, appears to become greater and greater as you move along to the left. To connect dr over dt and d theta over dt, we need to think about differential equations. Specifically, we know we can find dr over d theta by taking the derivative of the cardioid equation that is given as r is equal to 3 plus 2 cosine theta. We can then set dr over d theta equal to dr over d theta times d theta over dt and plug in the values we know. Specifically, the derivative of the cardioid is negative sine theta at the point pi over 2, pi over 3, and the value of dr over dt, which is 3. Using algebra, we can solve for d theta over dt as negative square root of 3. It is always important to check to see if a final answer makes sense with what we know to start. As the change in the distance from the origin to the curve is positive, it indicates the particle is moving towards the x-axis, which we said earlier, and therefore is decreasing in its angle. Hence, the negative change in the radians over time makes sense as a final answer. This concludes our discussion of question 5 on the 2018 AP BC Calculus Free Response section. We hope that you have found this video helpful.